This is part 2 of our tutorial on how to use Python to analyze your family tree. Part 1, you followed these steps. You exported your family tree to a GEDCOM file. You installed the free RootsMagic application. You used RootsMagic to convert your GEDCOM to a database. You installed Python with Anaconda, and you built your first Python script to analyze your tree. And now we'll continue on to expand our Python script to do some really useful stuff. I'm going to start my Anaconda environment, launch the Anaconda prompt, change directory to my working area, and run the command Jupyter notebook. And here is my browser, and this is the Python notebook from part 1 of this tutorial. So as a reminder, we set a variable to point at that database file with the .rm tree extension. We connected to it. We had a look at all the tables, and then we got down to work. We prepared a data frame that had all records from the person table, another one that had all records from the name table, did some analysis. We merged both those tables together, but ensured we only took the primary name for each person. We also had this additional column that we renamed to gender. We changed it to M for male and F for female. And finally, at the end of that tutorial, we exported this data to file with basic details of first name, surname, and gender for every person in your tree, which in itself is very useful, but you probably want more. At the very least, you probably want birth and death details. You may want marriage details, baptism details, burial details, funeral details, and this tutorial shows you how to retrieve them. Let's copy our first Python notebook to part 2. I'm going to select that notebook, hit duplicate, and then I can rename it here to part 2. I'm now going to open part 2. Here's some tips for the Anaconda environment. Suppose you want to clear the outputs, go up to kernel, click restart kernel and clear outputs of all cells. That just gives you a clean sheet. Now we're going to build on all the work we've done in that we still want these data frames. We're just going to get more data, but we don't yet want the output file. So I am just going to delete that particular cell. And for now, I'll just delete that header too. And we know that we're going to end with this person data frame. We've gone and restarted the kernel, which means that we don't have any data now in these data frames. So what I'm going to do now is I'm going to rerun the notebook from the start, but instead of stepping 2 as we've done before, running it cell by cell, I'm going to run to the very end. So I'm going to go to run, and I'm going to click run all cells. I could have clicked restart kernel and run all cells. We've already restarted the kernel to clear the display, so I'll just click run all cells. And you can see them running. There's that warning that we don't need to worry too much about, another warning. And here you can see that we're showing the first 5 rows from our final data frame from part 1, and it has our given name, surname, and gender details of every person in our tree. So the next thing that we want to do is, let's start with the birth details. The birth date and birthplace of the people in the tree where we recorded those details. Scroll up our notebook to look back at the cell where we listed all the tables in our database. The tables that we want to look at now are the event table and the fact type table, which records what type of event that we're looking for. So I'm going to come back down to the end of my notebook, give myself another cell, and now I am going to populate a data frame with the contents of the event table. I'm going to call my data frame df event table pandas.read underscore SQL select star from event table, and I'm going to use that connection. And once I've got those details, I'm going to take a look at the first, let's say 10 records. So the head function, but the default there is 5, so I'll give it a 10. Run that. What we have here is a whole lot of IDs that are lookup to records in other tables. You might recognize the owner ID here. It's a similar column to the owner ID in the name table, which was a lookup to the person ID in the person table. That's the same thing here. We're seeing an event type, we're seeing place ID, we're also seeing a date. What I really want to know is, well, these are clearly events that have happened to person. at a place, but what I want to know is what is the type of the event? Now, it's not obvious from the way that RootsMagic have named their fields. This is a lookup to a table called fact type table. So let's take a look at the fact type table. I'm just going to copy this down. I'm going to change my name to fact type table. I'm going to select star from fact type table, and then I'm going to show the first 10 records from fact type table. Run that, and here we go. Fact type ID number 1, and look, there it has the ID here in the name of the column. Number 1 is birth, number 2 is death. We've got a christening, burial, cremation, adoption, baptism, bar mitzvah and bas mitzvah, blessing, and then a whole heap more. We will look at the others, but for now we're going to hone in on birth details. So now we know that where we see an event type in the event table of 1, that is a birth fact. Just to show that diagrammatically, here is the event table, and then it has a lookup of an owner ID, it has a lookup of an event type, and that is a lookup to the fact table, which has a name that represents the type of fact it is. We've also got a lookup for a place ID, and we've got a date. If we put the picture together with the details that we had before, this is what the diagram looks like. We have the person table over here, the gender. We have the name table with potentially multiple names per person. And then for that particular person, they have multiple events. Each event has a type, which may be birth, death, burial, marriage, bar mitzvah, etc. Back to my notebook. And now that I know how the event table and the fact type table are related, I want a data frame that merges them or joins them together. I don't need all the columns, particularly from the fact type table, but I just merge the two data frames together, and then I'll focus on the fields that I'm actually interested in. We'll call my interim data frame before I focus on the actual fields I want. df merge equal to pd merge my events table data frame, df fact type table data frame. The columns I want to merge on, they have different names. So left on equal to the name of the column in the event table, which is event type. Right on the name of the column in the fact type table, which is fact type ID. Then I will show the first 5 rows. Run that. Okay, so now we've got quite a wide data frame. Here's these IDs 1, 2, and 3, etc. But if I scroll over to the right, I should see the fields from the event type. In particular, I'm interested in the name. I could explicitly drop all the fields that I'm not interested in, both from fact type, and then there's lots of fields in event that I'm also not interested in. But what I'll do is I'll give myself a new data frame called df event, and this I will assign or take from df merge. And now I'm going to simply name the column that I'm interested in, which is event ID, the owner ID, missing a notation. I'm going to take the family ID for later, the place ID, which I'll be using in this tutorial, the date, and that name from the fact type table. So the only field or column I'm interested in from that second table, the fact type table, is this name field. Once I've done that, I'll take a look at the data. So now I've got a narrower data frame with this name of the fact type over here. I don't like that column name because it's telling me that I am the name of your fact type, but now that I've pulled it into the df event, it's kind of lost its meaning, and I don't want to confuse it with the name of the person. So I'm going to rename that column. df event.rename columns equal to curly bracket name. I'll rename that to type as the new name. Close that bracket, and then in place equal to true. This is going to give me a warning, which I can safely ignore. I'll take another look at the contents. I'll just copy down that statement. There we go. There's my rename column. Let's do some data analysis on the events in your family tree. Let's look at the number of events in your tree per type. So I'm working on the event table. I want to group by the type, birth, death, marriage, etc. And then I'm going to count the numbers per type, and I'm going to call that count field count. Run that. This is for me. I use the AKA, alternatively known as, which is nicknames. Don't have that many baptism records, but the most common recorded event in my tree are birth records. I think it's easier to find birth records than it is to find death records. Here I have marriage records, few individual records here, and then the residence records, those are from the census. How is the ratio of event types in your tree could be very different to mine. I'll scroll up again to this event data frame. The next thing I want to look at is this place ID. If you're going to take a guess as to what it is a lookup to, you'd be right in thinking, if I scroll up again, right up to our list of tables, that it is a link to this place table. Let's start looking at this data. I'm going to give myself a heading in Markdown. I'm going to call it place details, and I'm going to mark this cell as Markdown. Run that. And then I'm going to select the data from the place table into a data frame. I'm going to call the data frame df place table, assign it to pandas read SQL, select star from place table, and using my connection variable. And then I'll take a look at the first few records. Run that. I'm going to focus in on the name. We've got Aba in Nigeria, Accra in Ghana, Adelaide in Australia. You're going to see the same names in your database, and if you're like me, you won't recognize some of them as being from your family tree. So let's explore this data a little bit. First of all, I'm going to count the number of rows and how many place names are there in here. So I'm going to use the len function on the data frame, 493. Suppose I say I want to see all of them. So I say, show me them all. Notice that that isn't going to work. So by default, the display of data using head in a pandas data frame will truncate. So here I'm seeing the first 5 rows in the table. I'm getting this truncation, and I'm seeing the last 5 rows. Well, I want to see the full set. So I am going to change the settings for my pandas package. I'm going to scroll right up to the top where I've done this already, but with the max columns. And now I'm going to set option display max rows, and I'm going to set that to none. And I run this again, scroll back down, and now I'll rerun this command with all 493 rows. As you can see in the cell, there is a slider. I can start scrolling down, and for you, if you scroll down to 201, you're going to start seeing place names that you recognize from your family tree. These entries are coming from my tree, but if I scroll up back again to the top, what's going on here is that the RootsMagic software has put a lot of towns and cities into this table. We don't need to be too concerned about that, because we know that the place IDs that are in use in our tree are linked from the event table. There are plenty of other records in that place table which won't have an entry in the event table linking to it, and we can safely ignore them. One more thing that is useful to know about the place table is that if you look at the place ID, it starts at 1. There's no row in the place table with a place ID of 0. Yet if we look at our event data, I'm going to filter the event data frame on the place ID where it's equal to 0, and I'll show the first 10 records if any exists. And notice that there are rows in our event data with a 0 place ID. These first few rows of type AKA have a place ID of 0. AKA refers to alternatively known as. That's a nickname. That's how I record nicknames in my tree. Understandably, a nickname doesn't have a place to go with it and doesn't have a date to go with it. In some database designs, instead of having a 0 in this field, where there is no 0 in the lookup table or place table, you might expect to see a null or unknown value here. That's not how RootsMagic is doing things. And that's important to know for the next step, where I want to merge my event data with place name data. In that, I'm going to have plenty of records in the event table that won't find a lookup for this place ID. I'm going to give myself a merge data frame, so df merged, assign it from pandas merge function, df event on the left, df place table on the right. The column in both is place ID, but now I want to specify what type of join I'm doing. I don't want to do the standard join. If I did so, because these rows here with place ID of 0, there wouldn't be a corresponding row in the df place table. I'd lose them from my merged data frame. So instead I want to do what's called a left join. And by using the keyword left, I'm saying take all the data in df event and join it to df place table on this place ID. But if there isn't a row in df place table, I still keep the data that's in df event in my new merged table. I'll just do a head on that, first 10 rows, and I will run that. So in this case, it's my first 10 rows that it's showing me. It happens to have a place ID. And notice now I've got a birth event here I'm merging it with the place table and I'm seeing the place name. That's looking good. But what happens for those rows where the place ID is 0? We just want to make sure that they're not being lost. So let's have a look at those and what they look like. So df merged, I'm going to filter once again where place ID is equal to 0, show the first 10 rows. And now you can see I still have the details in the event dataset or the event data frame. I'm not losing them, but because there's no data in the place table, this NaN stands for not a number. It just means that the data isn't there. Now, this df merge table has a whole lot of fields from the place table, like the latitude and longitude that I'm not that interested in. You might be. You might want the latitude and longitude. I don't. So what I'm going to do is I'm going to overwrite my current data frame of df event. I'm going to assign it from the merge data frame, and I'm going to name columns or fields that I'm interested in. So I want the event ID, owner ID, the family ID, just for future reference. I want the date, I want the type, and I want the name. And this name is what's coming from, I've got to scroll up a little bit, it's what's coming from the place table. Run that. And now this name is a bit of a generic column name, right? Name could mean a lot of different things. So I want to rename that to be a little bit clearer. This owner ID, to me, the owner ID is the person ID. I don't particularly like that name. I'm going to rename both those fields. So I'll give myself a comment to say what I'm doing. I'm going to set the new column names equal to owner ID. I want to rename to person ID, and name I want to rename to place name. So that's my list there. I am now going to use the rename function with the parameter of columns equal to new column names and in place equal to true. This I'm expecting to give me a warning that we've seen before, but I still expect it to complete. So this actually is giving me an error, not a warning, and it's telling me that new column names is not defined. So it doesn't like that, and it's right because I've misspelt it. I left off the S up here. So put that in, run it, and I get now, instead of getting an error, I'm getting a warning. But that's okay. And now I can take a look at my data. Now I've got this new event data frame, df underscore event, with this person ID. I've got a date. I've got the type of the event. And now I've got the place name. Let's take a more detailed look at the date column. You can see with a glance that it's not in an obvious format. For example, it doesn't seem to start with the date in the starting characters. The date looks like it's appearing here, then we have a few dots and some zeros. What's that about? So here's the quick and simplest summary of how dates appear in the RootsMagic database. Dates start not at the beginning of the field, it starts from the fourth character. The fourth character, you get a date in the format of YYYY for year, MM for month, DD for day. You'll see zeros for missing parts. So if there's no year, you'll see 0000 in that year field. If there is a year, 1971, and no month, you'll see 197100, and no day, that'd be followed by another 2 zeros. But what if you have dates in your tree formatted with it was before such and such a date, it was after such a date, it was between two dates? Well, that gets a bit more complicated. Too complicated for this shortened tutorial. I addressed that in the course. Go check it out in the link in the description below. So coming back to the display of dates, I want to apply an action to every single row in the event data frame that takes the characters from position 3. Bear with me, we're saying that this first position, this is position 0. Then we've got position 1, position 2, and this is position 3. And that means that the 12th character is at position 11. I want to strip out that part. But earlier, when we were looking at those AKA events, did you notice that there was no date? There was just a dot, a single dot. So with those single dot fields, if I go looking for the character position 3, I'm going to get an error because there's nothing there. That means that what I want to do is for every string that's long enough, I want to take the characters from position 3 to position 11. So let's write that. And to do that, we're going to use what's called a lambda function. This is a little complex when it comes to Python, so just follow along. I'm going to give myself a new field or column in the df event data frame. I'm going to call it date YYYYMMDD. It's going to hold this substring, and I'm going to take that from df event, the date column, which I'm going to apply a lambda function on x, where x is the string that's in the date column. I'm going to take from X, I'm going to take the characters from position 3 to 11, but only if the length of X is greater than 12. The length of X is shorter than 12, like if it's a dot, which would be a length of 1, I'm going to set it to an empty string. So let's take a look at that. So I get the warning, that's okay, but I also get the lambda function applied, and I now have this new column at the end of my data frame with the extracted substring. And that might be all you want. You may also want to split this single field into 3 parts. A year part, a month part, a day part, have those 3 extra columns in your data frame. The tutorial is getting a bit long, so I'm not going to do it here. I do have a section that does that in the course, but with just this single field, very useful. You can sort it so your events are in date order. That may be all that you need. So now we've seen the data that we want to achieve. Let's get at it. The first thing I'm going to do is prepare the birth data. Give myself a heading, change the cell type, markdown, and run that. Okay, what I want to do is create a new data frame called df birth that is basically a filtered data set from df event of all the rows that are birth rows. So assign it from df event based on df event the type. This is the column I'm looking at, and I want the type equal to birth. Double equal sign, birth. And I'll take a look at what I've got. I have a place name and a date column in this birth data frame that I'm going to rename those columns to be more specific to the type of event. You'll see why in a minute. So I'm going to define the new column names I want to use. So the date, YYYMDD, is going to be birth date, place name. I'm going to make it less generic. I'm going to change that to birthplace. Then I am going to apply the rename function on the data frame and pass it in that columns parameter of my new column names in place equal to true. And I'll take a look at the outcome of that. Usual warning in the course, I'll show you how to get rid of that warning, but we'll just put up with it for now. But here we see that we've got the renamed attributes. Okay, having done that, I now want to prepare the death data. By the way, I'm doing a couple of things here in several different steps that I could do all in the one step. It just makes it easier for you to see how I arrive at the final results. Cell type, run that. And now I'm going to do pretty much the same thing as I did up here. I'm going to give myself a death data frame. This time I'm going to filter out based on a type equal to death. On that, as you can see, it's got the filtered data. And once again, I'm going to rename the column. So I'll just copy down this and change the rename column to death date and death place. Change the data frame I'm working on. Run that. Exactly what I want. And now what I want to do is because I want the birth and death details for the same person to be on the same row, I want to merge these 2 data frames into a single joined data frame. I am going to give myself a heading of combine birth and death details. Now I'm going to get to work and take a couple of steps. So I'm going to call a new data frame df merge using the pandas merge function. I'm going to work from the left as the birth data frame, the right as the death data frame. The common column is this person ID. We need to think about how we do this join. We've seen a standard join, and we've also seen a left join. Now, in my family tree, and probably in yours, I have some persons that have a birth but no death details. I have some persons that have a death details but no birth details. So therefore, I want to use what's called the outer join. And that means if I have row, for a specific person ID, if I have either a birth row or a death row, my merged data frame will have a single row. It'll just put unknown, not a number, values where it doesn't have details. Let's see that in action. Take this one down the bottom here where I have a birth date in 1952, and notice we've got this not a number. There is no death place or death date information for that particular person with that particular birth date and birthplace. So I am going to clean up these columns and make them a bit more readable. I'm going to drop the ones that I don't need. But before I do that, I want to pull in the details of the person. I can't remember in terms of my person ID who is person ID 1, 2, and 3. So let me do another join. So this time I'm going to call a new data frame df merge person, and that is going to be a merge of this df merge data frame that I've just created. I'm going to merge that with df person, and in this case the linking column is the person ID, and I'm going to use the standard join. So I don't have a how equals to anything. If I leave that out as the standard join, because any person ID in the merged data frame has to be in the person data frame. Take a look at that. It's going to be a little bit wide and hard to read. Just want to make sure I've got those person details in there. So there we've got person ID. If I scroll over to the right, yeah, see over the right, I've got the given and surname, and the gender. Let me tidy this up a little bit and give myself a data frame that I might want to save out to file or use for reports. I'm going to call it DF birth death. It is signed from DF merged person, what I've just created, and now I am going to take the columns that I want, and I'm going to leave a lot behind. I'm going to take the person ID, given name, surname, birth date, birthplace, death date, and the death date and the death place. That's it. That's all I want. Do I want the gender? Sure, I'll take the gender. Why not? And let's see what that will look like on that. This, not a number for unknown value, isn't great for display. I want to deal with that. So I'm going to give myself a column list. Here's the columns. I've just named 4 columns because I will have a given and surname for the person ID. So it's birth date, birthplace, death date, and death place. That's my column list. So now I am going to act on my birth death data frame on the list of columns. So I'm just passing it in to the data frame, that list of columns, and I'm overwriting what's in there with the fill NA function. Fill NA acts on a field, like a single field. It is NA or not a number. And you have to tell it what you want if it happens to be an A. If it has a value in it, it won't act upon the field that you provided. If it is not a number, it'll do what you tell it. Here, I want to replace it with an empty string as type string. Now I've done that, I am going to show you what the results of that function looks like. Giving my warning, acting on a copy, but it's also giving me the data. And now you can see I now have an empty space instead of that confusing NaN. Let's take a look at more of the data. This is a really nice list of every single person in your tree. So to save this to file in a format in which I can open it up in a spreadsheet, let me give myself a new heading. We'll assign a variable called file name with the value I will call it my tree.csv. It's going to be a comma delimited file. So if I save it as a .csv, then spreadsheet applications, it'll help them recognize it as what that is. So that's just a file name. I need a full file path. Now, I'm going to put it in the same place. If I scroll up to the top, I'm going to save it to the same place as where I put the RootsMagic tree. You might want a different file path, right? But I'm just going to use that file path, which means that my full file, CSV file, is equal to, I'm using that operating system package os.path.join function, the file path, which is defined in the top cell, and that file name I've just defined here. And by defining that here, I'm using the same name as I use in the top cell, but I'm just overwriting that variable with this new content. And so now I have a CSV file. I now want to save the data frame to that file. So my data frame is birth death. I'm using the function to_CSV. I'm passing in the parameter of a CSV file, index equal to false. I'm going to run this, and then I'm going to go find that file. There is my tree.csv, just created that. Because I have Excel installed on my laptop, if I double click this, Excel will try and open it. Interestingly, I was wondering about the birthplace. How would Excel deal with the fact that the birthplace also has commas in it? It deals with it quite nicely, yeah. It's quite clever. Just to illustrate why it's being kind of clever, I'm going to open this in Notepad. So you can see what I mean by it's being comma delimited. So you can see that I have a comma here, a comma there, and a comma there. So it's splitting those. And the reason it's not splitting this particular address is that the saved data frame has wrapped that particular field with quotations. So Excel knows that when it's got quotations, treat that as a full string. Don't try splitting it up on a comma. If you go and import this into Google Sheets will also know that that is a single field. It'll recognize the quotations. So I promised in this tutorial that we'd look at other event types and not just birth and death. I can't predict what event types or facts you have in your tree. Let me scroll up to where we listed the fact types that you have in your tree with a count per fact or event. So you can see here's my birth and death facts, and we have previously merged the info about them into a single row. Just reuse the code in this tutorial for any of the other facts. I'll show you how to do that. Let's take marriage. I get asked about marriage a fair bit. So what I'm going to do is I'm going to scroll down to where I got the birth details, and I'm simply going to copy contents of this cell down to a new cell, and then I'm going to amend it to what I want. DF birth, I'm going to have DF marriage. I'm filtering on the type, and the type is equal to marriage. And let me show those details and run that. Now you can see that I have person ID, I've got this formatted date over here, and I've got a place name. And I just need to apply some of the same cleanup and transformations and merges that I did on the birth and death data frame. For example, I'll use the code that I showed you earlier to replace NaN with an empty string. And then in order to see the actual person, the given name and surname of this particular person, I'll use the merge function to merge DF marriage with DF person. Just to illustrate this, let me just bring this down. And then I'm going to look at my marriage data frame. As you can see now, I have the given name and surname over here with the gender. I have the place name that I intend to clean up, and I have the date details. You can do that for any of the other event types or facts in your tree. Well done for getting this far. This video is a shortened version of lesson 1 of our online course on how to use Python to analyze family trees. The course is based around 10 Python projects where we build up scripts to run useful analysis on your tree. Here's a course breakdown. You've already worked through creating the person list. Lesson 2 involves creating a surname frequency report, which will give you insights into the most prominent family lines in your tree. Lesson 3 shows you how to parse the addresses for the birthplaces and death places into manageable pieces for further analysis. That would be pieces such as the town, state, and countries into separate fields. Once you've separated out the addresses, Lesson 4 builds on this to create frequency reports for state, towns, and counties. This will let you identify key locations in your family's history. Still working with locations, Lesson 5 gives you the At This Place report, where you learn how to create a list of all the family tree events, births, marriages, deaths, etc., whatever you've added as facts to your family tree at a given location. Then we move on to provide a similar report of family tree events at a specific date. Lesson 7 involves doing some data cleansing on your family tree. So we show you techniques and queries to find duplicate individuals in your tree. Lesson 8, we look at some classic age issues. That would include individuals whose birth and death date mean that they must have lived 170 years. So something's gone wrong in your record. Lesson 9 is a gap report where we will identify missing details in your tree. That would include married women without a maiden name or all the people without a death location. Lesson 10, we show you how to extract the ancestral lines from your tree, grandparents, great-grandparents, and so on as far back as the number of generations in your tree. And Lesson 11 is a gap report. So if most of your ancestral lines are going back 8 generations, but you have a few that go back maybe 5 or 6, you can quickly highlight those and know where to direct your research. So if you're really interested in this course, it's not quite ready to launch yet. We'll put a link in the description below to where you can pre-register for the course for free. We just need your email, and we will send you notification of when the course lessons become available for purchase.